Hello, in this video we are talking about section 8.5 on power series. Specifically in day 2, we're working through some examples. So example 1 says to find the center, radius of convergence, and interval of convergence for the sum from k equals 0 to infinity of k factorial times x minus 1 to the k. So the first thing we'll do is find the center. Well, the center comes from when we take this power term and set it equal to 0. So if we set that equal to 0, we could take the kth root of both sides to cancel out that k there, so we get an x minus 1 equals 0, which clearly happens when x equals 1. So the center of the series is at x equals 1. The radius and interval of convergence are found together by applying the ratio test. So the same sorts of steps that we had when applying the ratio test to a series of all positive terms. We're going to set up and simplify our ratio first. So we will set up the ratio of a sub k plus 1 over a sub k. That's going to be k plus 1 factorial times x minus 1 to the k plus 1 all over a k factorial times x minus 1 to the k. That is in the absolute value. Remember that with the factorial, we can rewrite that as a k plus 1 times k minus 1, so on and so forth, down to 1, and the k factorial is going to be a k times k minus 1 all the way down to 1. So the only thing that doesn't cancel out in this case is the k plus 1 in the numerator. So that's going to give us a k plus 1 here. Those values are all positive, so you don't absolutely have to have the absolute values around them. For the other terms, our power terms, we're going to have almost everything cancel out, but we're going to be left with one little power of x minus 1 in the numerator. X is a variable, it can be positive or negative, so we do have to keep our absolute values around that. So this will give us a k plus 1 times the absolute value of x minus 1. Now we need to evaluate the limit as k goes to infinity of k plus 1 times absolute value of x minus 1. Now this limit is in terms of k, which means this term, the absolute value of x minus 1, isn't going to change if k changes. So that means that it is constant in terms of the limit, and constants can be pulled out of limits. So we can rewrite this as the absolute value of x minus 1 times the limit as k goes to infinity of k plus 1. Now as k goes to infinity, k plus 1 very clearly goes to infinity, so we end up with something like x minus 1 times something infinite, and the entire thing just goes off to infinity. Well, notice that this is never less than 1. For any x value, it's not going to be less than 1. However, we know from the notes on the previous day's lecture that a power series always converges at its center. Power series always converges at its center. So this result says it's not going to converge for any other x values, but it will still converge at its center. So therefore, the interval of convergence, which a lot of times I like to abbreviate as IOC, and you can feel free to do that in your solutions as well. The interval of convergence is the 1 point x equals 1. Since the radius of convergence is half the distance of the entire interval, and this interval is only 1, the distance of that interval is 0, This means that the radius of convergence, so the radius of convergence, which again I like to abbreviate with an ROC, and you can feel free to do that in your own solutions, is going to be R equals 0. So our three answers for this problem are, let me go ahead and box them in, x equals 1 for the center, x equals 1 for the interval of convergence, and r equals 0 for the radius of convergence. And that is our complete solution for example 1.